Hi guys, in our previous video, we try to learn about basic of analog programming in PLC. How sensor sense the signal and its transmitter send 0 to 20 mA signal to PLC analog card. How card convert it into 0 to 27,648 counts. And also made an example. In this video we will try to make more analog program. Example 01. Consider an example, we have a tank filled with oil. And oil is using for heating purpose. And process requirement is oil temperature must be greater than 45 centigrade. Heater start again if temperature decrease to less than 45 centigrade. After that valve will open if temperature is 45 centigrade and pump starts to supply the oil to process. Initially we filled the tank with oil. When we start the process, temperature transmitter sense that tank oil temperature is low. PLC gives command to heater to heat the oil. Temperature starts increasing. When temperature reaches above 45 centigrade, valve will open and pump start running to supply the oil to process. If temperature decrease to less than 45 centigrade, heater start again. Otherwise heater remains off. And valve will close if temperature decrease to 45 centigrade. In this example we require an analog input of temperature transmitter to measure the temperature of oil. A digital output for operating of heater. A digital output for operating of valve. Let's make a program in PLC. First of all we will give name and address to each used input and output. We can check the address in hardware configuration. First of all we will make a seal circuit, which will tell us that system is started. Define tags for system start stop. Now add a coil and give a tag for system started. We can use this output to attach a horn or light to tell in field that system has been started. Now we add a network and then insert a scaling block which will calculate the physical input and give the output according to set range. In our previous example, we have already studied about scaling function. Define high limit and low limit. Give a tag to bipolar pin. We are giving a real memory value to out pin for further use. Now we make logic for heater start stop. First we add a comparator which will compare the temperature with its set limits and operate the valve. If temperature is less than 45 centigrade it will start the heater. Add a coil for heater start. Attach define tag with coil. Make another network for stopping of heater. If temperature increase more than 60 centigrade PLC will stop the heater. Now we make logic for valve open and close. Use another comparator which will open the valve when temperature reaches to greater than 45 centigrade and pump start running. Add a coil for valve to open. Add another coil for pump. Attach define tag for valve and pump. Guys, we have already told you that it depends on programmer how he use the block and make a program. After finalizing the program, save the program. Download in a PLC. Let's check the program. When we press the start button our system started. Temperature is low so PLC will give command to start the heater. You see temperature is 0 and heater has been started according to designed logic. Temperature starts increasing. Now we slowly increase the temperature via simulator. And check the out value. Temperature is at 10 centigrade and our heater is on. Temperature is rising slowly. Temperature has been reached to 43 centigrade. Heater is on. Now temperature has been reached to 47 centigrade. Heater is on. Our valve has been opened. And pump has also been started to supply the oil to process. Now by increasing the temperature via simulator at more than 60 centigrade. Heater stopped. But valve is open and pump is running. Now we decrease the temperature manually. At 54 centigrade. Heater is off. Valve is open and pump is also running. We will receive the same behavior, until temperature drops to less than 45 centigrade. We see that at 45 centigrade valve will close, pump off and heater start again. When temperature goes back to more than 45 centigrade. Heater starts and also valve will open and pump start running. You see guys how simple is this? Now we make another example. Here we are controlling the temperature of water. Hot water is coming from any process and we are going to cool the water via using fan. A temperature transmitter is installed to measure the temperature. A fan is installed to cool the water. When we start the system temperature transmitter measure the temperature and send the signal to PLC. PLC control the fan speed via using a VFD. VFD increase or decrease the speed via taking commands from PLC. If temperature is high, PLC gives more setpoint to VFD to control the temperature. If temperature is low, PLC gives less setpoint. Let's make a program in PLC. First we define tags for all used inputs and outputs. Address could be found in hardware configuration. Define temperature analog input. Define analog output for fan speed. A digital output also defined for fan start stop. Now we make program. First make a seal circuit which will be used for telling in the field that system has been started. Attach tags for start input. Stop or emergency stop input. System started output. Now we make another network for temperature reading. Insert an FC105 for analog reading of temperature. Attach defined address of temperature. Define high limit and low limit. Attach a bipolar pin. Attach memory real value for output. This scaling block will convert the value of temperature from 0 to 27,648 counts into 0 to 100 value. Here we have used memory value. Why? Because we will use this value further for calculation. Now we make another network for fan start stop. Add a comparator which will compare the analog value of temperature with defined limit, which is 25 centigrade. Means when temperature of water rises from 25 centigrade fan start. And when temperature decreases to less than 25 centigrade. Fan stop. Add another network for sending analog out signal to VFD. Consider here we are making a simple program which will increase or decrease the speed via checking the temperature. Physically a VFD is used for taking the signal and controlling of fan speed. In our example we have also given a setpoint. For setpoint we could use a PID loop, which will automatically calculate the value and send the signal to VFD. Here we are giving a simple overview. On PID loop we will make another video. Keep watching our videos. Attach define tags with FC106. Define high and low limit. Attach output value tag. Now our program is ready. Save the program. Download in PLC. Now we test the program. When we press start button system started. Temperature is low. Fan is off. Now we increase the temperature via simulator. You see temperature is increasing. Fan is still off, because defined limit is 25 centigrade. When we increase analog value to 36 centigrade, fan started. And PLC also start sending speed to VFD to control the speed of fan. When we decrease value to less than 25 centigrade, fan stops. And speed also reduced. When we increase value to greater than 25 centigrade, fan start running. Guys, you see, when temperature increase, speed also increases. And when temperature decreased, speed also decreased. And when temperature decreased to less than 25 centigrade, fan stopped. So guys, you see how can we make logic for analog values. For more informative videos, stay on channel. Keep watching our video. Thanks for watching.